All right, recording is rolling. So this is open house. Got open house in front of me. So one of the first things I want to show is just Google Classroom's got a couple of codes. Yeah, coming in. So just for context, we're doing a recording. Just so you know, just full disclosure, we're doing a recording here. Welcome to open house. Right. Nobody's showing the video. It's just audio, and this camera's trained on right here. So here's a couple of codes. Let me switch my screen over so you guys can see where that's gonna lead. What fun adventures are we going on right here? Over here. All right, so here's what Google Classroom looks like. Now this is honors. Let me show you guys AP. There's a little bit different content, so some stuff that's crossover, right? But yeah, every day I'll post a class video that shows exactly what we did. So if you click on this, about 40 something minutes long, you can see exactly what we did today. By the way, what we did today was debriefed a lab that students did yesterday with spring scales. Gave them a bunch of spring scales and a bunch of activities to do with those, and went over step by step what I wanted them to get out of that right today. Right. Other stuff here, I'll post a different. Okay, so here's usually any documents that go in the class, I'll go ahead and post here too. So yeah, if they lose it, need to access it again, right? You guys can see exactly what we're doing. All these posters hanging around my room. If you want to download those, you get them here, right? So I've got a bunch of posters and a couple PDFs. There's some, let's see, page of the game on very first day of school. Oops, there you go, a few more, right? There's more, right? It's review pages, review the entire course. There's a bunch of variables and units in here, so I went ahead and put it in a convenient table so as to go along. Okay, tea time, we're gonna measure that in seconds. Okay, right, I said it there. Right, so that's a bunch of fun stuff there. I've also here's a AP classroom. So we just finished one of the assignments here. AP has these 7 sections they test for AP Physics 1. Okay? And students just finished a set of multiple choice questions. We went over the solutions to those. This was a pretty tough one I pulled up earlier today. It's yeah, so those things are all out there. Right? You guys possibly had a chance to, I don't know, maybe explore those in the time. Anyway, those are there. Right, let me switch back over here because I'd love to show you guys some stuff that we're doing in class. And if you guys have any questions about anything, then please do ask me. I'm happy to answer any questions you guys have. Right, so let's see if I can keep this approximately chronological. So one of the very first things we did was had students roll Hot Wheels cars down incline. In fact, well, this isn't going to show up on the video if you're watching the video at home, but in class, I got this incline over here. Okay, so this Hot Wheels car. Okay, drop this, rolls down. Got a speed gate right here. I see this. The car can build that speed gate. Okay, actually, I can flash these in front of the video, right? So the video is just right here is what's going on with this camera right here, right? I started recording during the pandemic, right? Because half my class were at home, and I was, oh, this is actually a really good idea. Students miss the class again, right? Right. So they just rolled cars down that incline. There was an incline at an angle, right? And then gathered a bunch of different data, like how fast was it going through the speed gate, like meters per second? How far did it go in centimeters as a function, like how much time? They got stopwatches. Some students were, I had them tape lab weights to the cars. What kind of effect would that have? Actually, let me ask you guys that. What do you guys think? Have you guys hypothesized? But let's see show of hands. Let's see show of hands. If I let the bike car go down the incline, suppose 200 centimeters takes some amount of time. What do you think happens if you take this big old lab weight to the car? Is that going to make the car get to the bottom, say, faster or slower or same?
You evacuate the atmosphere.
Yeah, we make sure you do that. So we got our oxygen masks on. There's no air in here, right? Okay, yeah, you know what's going on, right? How many guys think it makes the car reach the bottom of the incline faster? Who says same time? Who says same time? Does anybody say slower? All right, yeah, you guys know this class. It is same time. It is same time, right? Oh, and maybe you know from before. Maybe you know because here's the answer right here. This is actual real-time data I just gathered from the class. They told me, right? So we got different mass cars, we got light cars, we got heavy cars, mass in grams, right? And it looks like the time was pretty consistent over and over, about 3.5 seconds for whatever rolling distance that was, right? This is actually a slowed down version of arguably the experiment that kicked off all of modern science. Do you guys know the story of Galileo and the Leaning Tower of Pisa? Right? Galileo runs to the top of the Leaning Tower, drops this and drops this off the Leaning Tower. Which one hits the ground first? Same time, freaks everyone out, like, oh boy, we're in a different era now. And then, a few hundred years later, now we got computers and stuff. So yeah, same time, right? Now, why is that? See, they got different weights, they got also different masses, different amounts of inertia, right? Those two effects cancel each other out. Right, about to be getting this down. Yeah, so what's the rest of these results from this lab? So it looks like the mass of the car had no effect on its rolling time, right? Just like Galileo figured out. What's the relationship between distance and time? Like how far it rolls in centimeters is function of time. That would be like a parabolic relationship. One skill that AP wants students to have is to linearize graphs. So if you do x versus t squared, that linearizes it. One advantage to doing something like that is you can very quickly whip off the slope and whip off an equation. Okay, so now we got like something to do with that relationship. What's the speed of the car as a function of time? So it's rolling through the speed gate. That ends up being a linear relationship. The slope of this tells you like the acceleration of the car. Right? And then finally, I had a team of students say, hey, what's the speed as a function of distance? That ends up being like the square root type, right? And you can also linearize that by squaring that type, right? What students were able to effectively do then was derive these three here kinematic formulas, these expressions, right? So poster I've since moved to the back of the room because we're like moving on to new stuff, but you might see it hanging in the back there in the middle. Okay? So this all came exactly out of that lab data, right? And a lot of labs like that in this class. We do lots of labs, and like the end result of these labs, you open the textbooks, like, oh, well, there's the answers. So students are discovering stuff just like Galileo or Newton would discover things back in the day that come across these. They get to apply these and do more fun things with these. More fun things being, well, I'll show you guys one more fun thing. Let me read this. We took this and expanded this into 2 dimensions. So looking for a specific, is it here we go. Right. What if we take this here blaster, right? This blaster, right? Let me stuff this thing. Right. Ooh, it's got a spring in it. Right. Can throw this ball in here. Right. Can you guys imagine this launcher? It's like on the edge of a ledge. Right. Ooh, that rhymes. So we were outside on the balcony. Right. Students measured what's the height of this balcony. They blasted this thing. Let's try this out. Ooh, oh yeah, fun days. Right. And then spot where the ball lands. Now, if you know how far it falls, where it lands, because you spotted it, you measure those. And you also know something about maybe the strength of Earth's gravity field, like something that would cause it to like bend down into this parabola shape. Do you think there's, in principle, enough information there where you could determine what's the blast speed? What's the blast speed, right? Okay. Reveal a solution to this. Yeah, I've been teaching this class for too many years. I'm just gonna make all my notes look real pretty. There you go. So, all right, here's something to do with it falling in Earth's gravity, how much time it takes to fall. Here's spotting where it lands, horizontal displacement, right? They're tied together by time. You can do a little substitution and bam, you can get the blast speed as a function of where did it land, what's the height of the ledge. You can even switch planets with the gravity field. You can put this on Mars and swap that in there. One skill that AP wants students to have is to be able to solve in terms of variables like this, right? You take a basic expression from their car and ramp lab, right? Great. And then do a little bit of algebraic manipulation. Now you can start to build like more complex ideas, right? Right. So yeah, that's a skill students are gonna have. Right. Students just turn in their first quiz for linear motion. Okay. Now scores for that were kind of all over the place. Some students did really awesome. Some students really struggled with that. I'm going to do a partial credit back opportunity. So actually, students for AP just got their quizzes back, and I posted the solutions to AP Classroom. So all the solutions to the last quiz are in AP Classroom. Any questions that students miss, they just handwrite out the solutions, turn those into me, and I'll give them a partial credit back. It's not like you get really challenging questions that really make them like, sit down and have to think deeply about it. Right? And then, yeah, they can get partial credit back if they go through and show they can do it. I've been doing take-home quizzes for the last few years. I started doing it with the pandemic because it's like, okay, well, it's like half the students are at home, so maybe they'll like level the playing field. That's another thing I ended up keeping since the pandemic, right? Like recording lessons, put on Google Classroom, also doing take-home quizzes. There's some advantages to that. One is that I get more class time to do like more labs and stuff in class. Another is that yeah, like students can really sit down and think like more deeply about like some pretty challenging questions, right? And then there's always like 10 different versions of the quiz. So everyone has something a little bit unique, and then come turn those in and yeah, gives you some pretty accurate grades too. So so that all works out. Right. So we've since moved on to see, we're doing forces. Right. So last lab they did, I gave them a bunch of spring scales and lab weights and had them do a bunch of activities. Now get to this. Right. I want to take you guys through this, but it sounds like they're gonna about to be sending you to 7th period here. Right. I guess just real fast, if you got like two dimensions, suppose you got spring scales, you got a weight here. There's a principle here of like static equilibrium. Suppose you're an engineer building a bridge, right? Right. You might want to know what parts of your bridge are in tension or compression. Can you calculate that? It's based on this principle here. And then furthermore, if this is made out of materials like steel or concrete, which have certain compressive or tensile strengths, like how much material do you need, right? So it's all economical, right? So that's good. Right, so a lot of fun stuff in here. Lots of labs, lots of graphs, lots of getting your hands on these materials, doing lab. Lots of taking big complex ideas and breaking them down into some fundamental things like laws of motion. But all right, so hope you guys are having a good night. You guys ready for next class here? Yeah. Thanks so much for coming in. I really appreciate you guys coming in.